Meet Balluff's latest IO-Link condition monitoring sensor designed to give you a deeper, smarter insight into your machines. Whether it's motors, bearings, pumps, or gearboxes, vibration is often the first sign of trouble. The new BCM sensor captures more than just the basics. It provides temperature, vibration velocity, acceleration, and now real-time FFT data to help you pinpoint issues before they become major problems. FFT data breaks down raw vibration signals into individual frequency components. That means you can isolate a problem to a specific source and identify the root cause. So instead of just saying something's wrong, you can now say this bearing is starting to fail due to an abnormal vibration in the inner ring. To show you what that looks like, I got the new BCM sensor wired into Balluff's condition monitoring toolkit, what we call the CMTK. The CMTK was developed by Balluff as an edge device to monitor and visualize data from any IO-Link sensor. It can send email alerts, log data, and even handshake directly with the SCADA system. But for today's purposes, I'll be using it to show how FFT data from the new BCM sensor is captured and displayed, and how that data can be used for smarter, more targeted maintenance decisions. Hopping over to the CMTK software, it's just a web browser. So here we can see the connected devices. So you can see that I have currently 2 sensors connected. One of them is the sensor sitting here on the table. The other sensor is the one on the side of this motor. So I'm gonna walk through how we set those up. So when we originally first started getting these types of sensors, a lot of people didn't know where to set their thresholds. So we would put a sensor on a motor like this, and we would just start monitoring what we considered a baseline. But from there, how do we know where to set our upper and lower limits? What's considered healthy vibration or bad vibration? That might lead to us potentially taking a motor out of service before it's fully ready for it to be repaired. So how do we look at that? Balluff created the BCM Assistant. So now this is a tool that allows us to easily set up motors, pumps, bearings, fans, whatever the asset is you're trying to monitor. And actually it tells us where we should set what's healthy and bad vibration. So walking through this here, you can see I don't have this sensor set up. So this is the sensor that's on the table. This is the new BCM sensor. So if I open this up, you can see, we can just select what type of asset we're monitoring. So if we go to motor, now we can come in and go through these different options. So the first option would be setting it up by its power class. So this is a really easy option. We just say what kind of power class it is, the appropriate shaft height, the rotational speed of the motor, the appropriate how it's mounted essentially. So is it rigidly mounted, elastically mounted, and then also where we have the sensor mounted on the motor. From here, we click through this. It now gives us the actual ISO standard for a motor of that size and what they consider healthy vibration. So you have your pre-alarm and your main alarm. So yeah, it walks through that step by step. We can also come in here and set temperature. I'll show you guys that here in a second. We can also do the bearing frequencies. So this is where we're actually going to see the FFT analysis. Since FFT is dependent on the rotational speed, it gives us a couple different options. So one option is we have a simple prox sensor connected, so you can walk through and how they have recommendations on how to set that up. The other option is setting the rotational speed from the PLC. So if your PLC knows at what rotational speed your motor or bearing is spinning, it lets you set it there. The third option is setting it with a static rotational speed. So for today's purposes, I'm just going to, for example, set it up with a static rotational speed. So it's just giving me a warning saying that the rotational speed is typically going to vary, and you might have an alarm go off at the beginning of your motor startup. So if I set the rotational speed to 1,000, hit next, we can actually, another option now, we look at the bearing itself. So now we can search actually the CMTK's database. So if I know my manufacturing part number for my bearing, I can actually type that in and actually pull up that bearing here. Or we can use a bearing calculator or manually input it. So I'm going to show the manual input first. So manual input, if you know what frequency range that your inner part of your bearing is supposed to have, or your outer part of your bearing and the rolling elements have, you're more than welcome to set those here. For today's purposes, I'm going to show you guys the bearing calculator. We come in here and we actually look at the number of rolling elements, the rolling diameter, the pitch diameter, and the contact angle. Once we have that set, it actually tells us what our frequency factor should be for the inner, outer, and rolling elements of the bearing. And now we can name that. So we'll say bearing 1. Hit done. So now we just set that bearing up. Now we can add another function, so I'm going to add the contact temperature. We're going to manually set that. So here's your minimum temperature, your maximum temperature. I'm going to set that to 35. And we'll say bearing temp. Done. And then we can upload this to the device. So once you have that set up and we move over to the visualization software, you can see here, this first dashboard here is showing the RMS. This is the motor. So you can see the vibration on that. This is a really small motor, so we're looking at the acceleration or G's of this motor. Since it's such a small motor, it's not really going to show a ton. But now we just set up the bearing. So that bearing is what I was just explaining to you guys. We can see the outer, inner, and rolling elements themselves. So that's what this is showing here. We have the X, the inner, the outer, and the spinning rolling elements themselves. So once you have those set, we can come in here and we can actually set alarms to be notifications. So right here we have an evaluation for 10 seconds. We're going to choose that on, say, the inner, and it's going to be an average. The reason we do an average like that is because if there's any kind of odd vibration in the system, you don't want an email alert or notification always firing off. We want to see the average. So now at any point, if that bearing starts to fall out of whack for more than 10 seconds, we'll get an email notification letting us know something went wrong. If you guys would like to learn more about condition monitoring and how it can benefit you, head over to neffautomation.com or reach out to your local NEFF representative and we will be happy to help you in your next project.